Hello, I'm Kevin Benedict, Senior Vice President of Solution Strategy here at Regalix, and I want to welcome all of you here today. Now, today I have a friend and guest, Rob Tiffany, who's, he's CTO and Global Product Manager or Global Product Manager for Lumada IoT at Hitachi Vantara. Boy, what a mouthful, Rob.
It's a mouthful. You're right. Usually you're not a CTO and a product manager. Those seem like two different things, don't they?
Yeah, so how did you end up combining those two roles together at Hitachi?
Yeah, you know what? When I joined Hitachi, the role was, kind of global product manager to drive the creation of this industrial IoT platform. And I've had, obviously, at Microsoft and a lot of other places, I've had a lot of roles where I was doing, senior and executive level PM type stuff. But I also am technical and can build the actual stuff and design it and architect it and everything, which was great. And so I got the CTO thing as well. So it does seem kind of strange, but it's all worked out, luckily.
Oh,
Vizio.
CTO, Global Product Manager, and former submariner.
Yes, yeah, that's true.
I saw that on social media this week that somebody interviewed you about your wartime experiences on a submarine. Give us, in a nutshell, what was that about?
The submarine thing was great. When I was in my early 20s, you're a kid. I joined during the Gulf War. And so I was on two different submarines. The first one was actually a SEAL team delivery vehicle submarine. So it was an old ballistic missile sub from the 60s that had been converted. They took all the ICBMs out to have a berthing space for the teams, for the SEALs. And so that was during the Gulf War, doing some crazy stuff there. Really cool James Bond kind of stuff, too. That submarine had mini subs on the dry deck shelter on the top of it. A ballistic missile sub kind of has a flat deck to it.
Yeah.
The thing's open. So there was this shelter and two little mini subs. So the SEALs would do that. And so it was crazy. It was just like movies you might see. On a Trident submarine, which is, they call it the President's Gold Watch, is what a Trident submarine, the Ohio class. And basically that has the 24 Trident II missiles on it. So totally different mission. You're just kind of cruising around, being quiet, waiting for the message from the president.
Well, nowadays, you never know what that message might be.
You might get a tweet.
So, Rob, you and your product team have been getting a lot of accolades recently. I just read this week that you guys made the Visionary Quadrant for Gartner's Industrial Internet of Things Magic Quadrant. Congratulations.
Thank you. That's pretty exciting stuff.
It is. And then I see you got the Hitachi President Technology Award for the Best Product of the Year.
Yeah.
IoT Breakthrough, Hitachi Lumada IoT Platform is the 2018 Enterprise Solution of the Year. I see Computer World saying the most powerful Internet of Things company is Hitachi Vantara. And then I see Internet of Things Institute lists Hitachi's Lumada is the top IoT platform of the year back in 2016. Your team has been doing a lot. Congratulations on that.
Thank you so much. We've been pretty heads down, working hard for sure.
We'll dig into, what's everybody seeing out there with your product. So let's talk about first Lumada. What does that mean to us? Where did you guys come up with that name?
Doesn't that sound like a deal where you have focus groups or you hire some marketing company to figure out a name? It's
or you sit in front of a domain name and a domain name that's available, right?
Yes, yeah. So Lumada actually means illuminate the data.
That makes sense.
Yeah, that's kind of, the backstory, so there's Hitachi Limited, which is a giant industrial conglomerate in Japan, similar to Siemens or GE. And then, it's got all these subsidiaries that roll up to it. And so here in the US, we have a Hitachi Vantara, which is a kind of under the umbrella. But when you think about data, it kind of goes back in time. Prior to the Vantara name and all that, there was a company called Hitachi Data Systems. And so their whole gig has been, storage arrays, servers, that kind of thing. Not unlike EMC, maybe, things like that from the past. And so Vantara was kind of that storage data business, building specialized object storage and content management systems, combined with the Insight Group, which I was part of to build the IoT technology, and then Pentaho, which was our advanced analytics platform. And so the coming together of those three groups created Vantara.
Oh, very good. And what does Vantara mean?
I have no idea.
Okay.
I
was hoping I could stump you on something today.
It did. I don't think it had. I don't know if it means anything. Actually, I think it was just a name.
Oh, that's great.
It was better than just calling it Hitachi Digital.
Okay. So for those of you that don't know Lumada IoT, the Hitachi Vantara platform that Rob is responsible for here. Rob, give us an overview. What's included in that?
Yeah, absolutely. If you're familiar with the IoT space, which, there's no shortage of hype and talk around that over the last 4 or 5, whatever years. But you know what? It's really focused, so an IoT platform, there's lots of elements to it. You've got the machines themselves, so, and also to be clear, we're really focused on the industrial side of that space. And so we didn't build this stuff in a vacuum. This whole thing came from Hitachi in Japan. And I spent most of my time with working groups and living in factories and working with folks in Japan to build something that's legit. There's no shortage of IoT platforms that are built for Raspberry Pis. Obviously, we're not that. We build bullet trains and factories and industrial robots and all kinds of stuff. So it starts with the machine itself. You've got microcontrollers on machines. You've got sensors. You've got to get that telemetry in, to a platform. You probably hear a lot of talk these days around the edge or the fog and things like that. What that's talking about is really getting close to the machines. And so one of the things, so if you think of Lumada as, hey, I can connect machines, I can collect the data. We use something called asset avatars. If you've ever heard the term digital twin, it's similar to that. And then, so we have these, avatars that digital representation of physical machines that you can query, or you can have real-time streaming data. And then we have our Pentaho technology, which is our advanced analytics stack, which has this really easy visual drag and drop tool to move, once you capture data from your machines, it's like, okay, I've got it. What am I going to do with it? I need to analyze that data. I want to get some insight, and then I want to take action on that insight so that there's value for having this whole thing. So Pentaho lets you visually drag and drop all that data from our digital twins, our avatars, and move it into either streaming analytics, and that stuff's built into Pentaho, but it can also work with other things like, like Apache Spark or Flink or things like that, Hadoop, and batch type stuff, doing predictions against R or Python, things like that for predictive maintenance. And then outcomes, what do I do with that thing? I'm going to visualize it, might be one outcome, and Pentaho provides, visualization, dashboards, reports, things like that. Also, has kind of a way to notify folks or machines to take action automatically. One of the things that I think was really helpful for us, probably with this Magic Quadrant, is enterprise integration is so critical. You can build a system that can talk to machines and get the data, send commands back to data. But sometimes a weak link is your ability to tie in all of the customer's existing enterprise systems that they already have. Because you need to, if you got data coming from machine number 25, and how do you know what that even means? So you need to get context from that. And so Pentaho has 100+ data connectors, kind of, if you know, like ETL kind of things like that. But easy to use connectors. I'm not talking about writing code for, web APIs. I'm talking about drag and drop connectors, like I need to plug into this database or plug into SAP or whatever, do transformations, things like that. So our ability to use those connectors coming in, so as machine data is coming in, also business data can also come in. We blend those two together to add context and meaning to find out what's really going on here. Also, on the output side, once I have an action I want to take, if I need to fix, my predictive analytics tells me a piece of machinery is going to fail and I need to fix it before it fails, rather than necessarily just having a big red light flashing on a dashboard, why not use our connectors to automatically flow that message into a customer's existing maybe ERP system or a trouble ticket, a service platform type thing. And so we can use that. I kind of think of it, a lot of this, we all bring so much, hopefully, wisdom with us from all the things we've done in our careers. And so I used to spend time building platforms for the financial services industry and trading instruments. One of the technologies or common things was called straight-through processing. After a deal is done, you bought a stock or a financial instrument or whatever. There's all these other steps that happen after that are usually human-based. Straight-through processing is taking the human element out of that and automating all those processes.
Oh, wow.
That's what I did with Lumada, is use those same connectors to just take care of it, take care of the problem. Because ultimately, IoT is so big, so many machines, so many devices, there's no way any one person or group of people can manage the whole thing on their own. It's tough. And so the more you can automate and have it automatically happen, right?
So you have best practices built right into your algorithms.
Absolutely. Absolutely. Yeah. The more the system, Lumada can just do everything for you end to end, the better, so that the whole system can be just kind of running on autopilot.
So Rob, talk to me about the secret sauce in your platform that's resulting in all these industry accolades.
Well, I think we start off with having street cred for being an actual industrial conglomerate. And so we started with real machines. And so I would say, of all things, because you know what, being really frank with you, as you probably know, there are hundreds of IoT platforms and they probably have more in common than they do different. They all do a lot of the stuff the same, right? I connect, I collect, I'm managing data and storage. I'm going to analyze it somehow. I'm going to do something with it. And there's hundreds of these. So I think where we are different, I think a few things. The avatars, our digital twin, I think sets us apart, and plus our vision. Part of it, like when you talk about Gartner, why did we end up with the visionary quadrant? It's completeness of vision, right? And so our twins plus our our roadmap, where we're going with this stuff, played a big role in with Gartner in doing that. So the way our avatars, many systems out there, and there's lots of great systems. They typically, it's very common to see a digital twin for the systems that use it. It's not very many systems use it right now, but they may model a digital twin maybe in JSON, for instance. And so you might see a kind of a flat JSON model that's mapping one for one each sensor, for instance, and that kind of stuff. So you create a mirror image. We do that too, of course, but we go beyond that, for every kind of sensor that's coming off, or we think more about it. We start off going, Hitachi deals with big, complex machines, not Raspberry Pis. And so systems too. And so we make sure that our avatars, we have different avatars for different subsystems. Let me give me an example. Let's make it something everyone can understand, like a car. Mm-hmm. I could have an avatar, a digital twin for a car, and have the hundreds or thousands of different sensors or data points coming off a car, all in kind of a flat JSON model. But you and I know that a car has super complex subsystems that maybe should be an avatar into themselves. The engine itself is infinitely complex, and the transmission. And so what we do is we make sure we have separate avatars for all these complex subsystems in a machine, and then they roll up to the kind of a parent-child relationship, as you might imagine. And so it says, we don't just do one simple avatar, we'll do multiple avatars for systems. They all belong to this system, this big avatar, like a car. And then we go further than that. Let's say I've got all these factory machines and they've got complex subsystems with all their own avatars. All those machines working together can comprise an assembly line, right? In a factory. So we'll have an avatar that represents the assembly line. and all the machines that make it up and that kind of stuff. And then we go further than that. How do I represent an entire factory as a living thing? So representing factories and multiple factories as avatars, so that a company can get this really massive view. And an avatar is not just trying to be a group. It monitors all the sensors. It also then has rules associated with it. It has all of these other, that digital representation of the physical object. You get to put more stuff basically on the digital side. So for each sensor, I can also say, oh, well, here are the associated KPIs that go with that. Here are thresholds, and then here's code I want to execute. And here's a whole lot of other stuff that goes with it. And then here's information about when I'm doing maintenance on these things. And then being able to say, when I did maintenance on this machine, did it get better or worse? Because you use digital twins to kind of help you in the moment, in the future, to help predict failure and things like that. But you also ultimately will use it. Did we get better? You'll use them to do simulations. Ultimately, there's a feedback loop in the creation of new products. What did we learn from this digital twin? And can I fire fake data into this twin and have it fire all the rules and all the fun stuff that goes with that and see what happens, so that I can kind of fake out and create possible failures or things like that. And so ultimately it drives back into the development of new products. How do I make new Hitachi hardware better? I could go on forever, but I think you get the gist of it. And so we went all in on the digital twin, but also one other thing I want to point out. It's a powerful concept. There are companies that's all they do is digital twins. And I've seen some amazing things. I've seen companies where they represent entire container ships as 3D CAD models, and that's what they think of as a digital twin. And it is awesome. What's important, though, is to not overwhelm the customer, though. Because if a customer starts thinking that the only way they can do IoT is they have to build some crazy 3D CAD model of each thing, that may seem like too much of a task for them to do. So our focus was almost everything is optional. You can build just as much as you need to build to get value. And if you want to go crazy and build a 3D CAD model of a container ship, knock yourself out. But we definitely want to make that optional. So that's kind of the gist of it. These avatars representing all kinds of things. You may have heard, Jim Heppelman over at PTC has been a prolific writer for years in Harvard Business Review of kind of maturity model around IoT. And ultimately, at the end, you get to this notion of systems, right?
Yep.
That's what we do. Our system, we can have multi-company systems, multi-factory. I'll give you an example. And a lot of this is, if you're familiar with Industry 4.0, which was started in Germany, how do we make some of those, dynamic scheduling, custom build to order stuff, breaking away from the Henry Ford assembly line to mass customization, or Uber-like things like sharing. What if Hitachi at a Hitachi factory in Japan has an idle assembly line, and maybe Toshiba or Toyota or somebody wants to use that while it's idle? How do we facilitate that sharing of things like that? All of those crazy ideas went into Lumada, and we modeled that stuff and so I think that's probably where we got a lot of love from a lot of folks. With our completeness of vision, to make sure that we weren't just doing the simple stuff. We were going into the future, because a lot of people want to realize this whole Industry 4.0 vision, and it's not easy. So
there's a big difference between having your Fitbit and having it show up data on your iPhone, and what you're talking about, a system of systems that really gives us the definition of industrial Internet of Things.
Yeah, it's pretty hardcore. And of course, we got Pentaho, all those connectors, that enterprise integration. That's a big plus that helped us with our completeness of vision, because customers need to plug all this into their existing systems. You can't just, what customers don't want is just yet another platform and another silo of data in there. They want everything to work together. And so having that integration was also, I think, a big help for us to make sure that we play well with others and all the data comes together, because it all matters.
So Rob, when you sit down with a client today, are they do they come to you educated in all these concepts about systems of systems and Internet of Things and identifying blind spots where they need more data, and so they need to find kinds of sensors in there, and then we need to bring it in, and they need to automate it and create the algorithms based on best practices? Do they already know all those concepts, or do you have to educate them once you've met with them?
It depends on who it is, but yes, education is certainly a part of it. If depending on who the customer is, so you can imagine, first and foremost, Lumada is there to make Hitachi a more valuable company and make its products more valuable in the marketplace. Long before we decide to, hey, let's go battle it out with 700 other IoT platforms to see who wins. That was not the primary objective of Lumada. The primary objective is make Hitachi's equipment more valuable and make Hitachi, a more agile company. We often talk about, Hitachi is like 106 years old, but in order for us to survive for the next 100 years, we need stuff like Lumada, which then facilitates the twins, which then facilitates AI, ML, deep learning, all that stuff to make ourselves more valuable. So if it's Hitachi, obviously, a lot of what we think of as IoT, keep in mind, comes from the industrial world. So companies like Hitachi and GE and Siemens and others have been doing machine-to-machine stuff for decades, and they've been doing their own analytics. So that's not new for them. So if it's if it's us or somebody like that, they may be pretty savvy about that kind of stuff. But you're absolutely right. If it's some other customer where this is new to them, there's no shortage of education. And so we lean on professional services organizations. We have our own internal professional services, as you can imagine. We have Hitachi Consulting, as the kind of that first line of helping us with that, and so they're all trained on Lumada. They all know the industrial world better than most. And then, of course, all the global SIs that you can imagine, training them so that they can deliver those kind of things. Because you're absolutely right. Education is a big part of this. You want to get to value fast.
So in wrapping up our conversation here, Rob, every time I go to the Mobile World Congress, one of the most exciting parts to me is walking the floor and looking for the unique and interesting kinds of sensors. Because sensors, in a lot of ways, those are the tip of the spear, the device that captures the data and measures the data. What are you seeing out there that you find most interesting today?
Wow. Gosh, I'm probably the wrong person to ask. There's some cool stuff out there. Hitachi makes a lot of that stuff, but I think the most of the world, when they think of sensors, and it's probably still a small club, I love the stuff you got from, Lobilium or whatever in Spain. They make so many, a lot of the stuff you're seeing that are helping facilitate kind of smart cities, smart spaces, is certainly exciting, around traffic flow, around things to make a city operate more efficiently. I could certainly bore you with the the mundane vibration and other kind of sensors that we use.
I'm listening to these guys talk about sensors that can smell. So smartphones in the future can have carbon monoxide detectors, and just, they can tell you about all kinds of, you're exposed to radon, all these kinds of things, and your smartphone smells things. That kind of thing is just really interesting to me.
It is. And, I don't want to sound jaded, but let's go all the way back to my submarine days.
Yes.
Before you hear me kind of roll my eyes at things and say, none of this is new, it's because none of this is new. So think back to my submarine. Think of all the gas sensors. So we had sensors for carbon dioxide, because we don't want to all just go to sleep and not wake up on the sub, right? We had sensors for every kind of gas you can imagine, because NASA started working with the Navy years ago, because the Navy had a program back in, I don't know if it was the 60s or whatever, called SubSafe. And NASA adopted that because the closest thing to a spaceship in space, where it's isolated, that can't get any help from anywhere, is a submarine. They're both in the same boat. And so like NASA spaceships, submarines are equipped with so many sensors because we have to be survivable, right?
Yes.
So all the gas sensors to keep people alive. Submarines make their own air from seawater. Remember all the little chemistry we learned breaking apart H2O. We desalinate water to have drinking water, and we have a nuclear reactor that lets us go for 10 or 15 years without refueling. So, the only thing that's slowing you down on a sub is food, basically, right?
Mm-hmm.
But we have so many sensors on a sub to make sure that we are all still alive. Radiological stuff, you've got a reactor. Is there a leak? Every sailor has a little dosimeter. They call it TLD. They wear on their belt to measure how many rads they're getting. Things like that. I could go on forever. All this stuff's been around. It's been around since the 60s, maybe the 50s, and further back.
It was just a little too big to fit in a device like this, right?
Yes, and you know what? And that's a good point. People wonder why IoT is talked about now. If Jaded Rob here says we've had all these things forever, if we've had sensors like this forever, if we've had advanced analytics like this forever, why is it a big deal? Money. There's a perfect storm going on. All of a sudden, these sensors got really cheap. Sensors that used to be the domain of the government, wealthy companies that could afford that, microcontrollers that are connected to machines that used to be hard to find, proprietary, expensive, that's getting cheap. There's so many out there. The consumers know about Arduino and Raspberry Pi, and there's zillions of others that are really tiny. And also, I want to send props out to Microsoft for their Azure Sphere microcontroller. I saw it build. I was really impressed with what they're doing there. These platforms to collect data. What else got cheaper? Storage. Storage costs are, they're going to zero, right? In the cloud, for sure. Analytics used to cost tens of millions of dollars for wealthy companies or the government to buy those. Well, now you can just go to apache.org and download an analytics package for free. Now, you still have to know how to use it, but you can kind of see we have this democratization going on, and it has to do with just dramatic drops in costs. So now it's available to everyone. I think that's why IoT is so big now, is because everything got really cheap.
Well, on that note, Rob, I want to thank you so much for sharing your experience, for your service to the country as a submariner. Absolutely. Thank you for that. And just sharing your experiences, wisdom, insight around all these things to us. Thank you so much, Rob.
Well, it's my pleasure. It's always good to chat with you.
And thank you, everyone out there, for watching as well. Thank you very much.